Started. All right, here we go. There's some, it looks like 139 has the most interest for us to talk about. So let's work on that one. So here we go. All right, so the first thing we look at is we ask, and this is going to be, it may not seem important now, but when we get to these harder problems, it's going to be really important. The question of what's the overall structure? That's the first question we ask. What's the structure in 139? So the structure in 139 is sum, just the sum of three things. So we're going to do the individual derivatives or rate of change functions for each thing that we're adding together. Remember, that's like the easiest rule there is, right? So we're going to do the rate of change of this plus the rate of change of that minus the rate of change of e. So we start with radical 10x. So that is a composite function. That's the function. The interior function is, what's the interior function? 10x. And the exterior function is square root of x. So we have to apply that last rule that we had on, let's say, Tuesday. So that last rule that we worked on Tuesday was what we call, I don't know if we named it, but it's called the chain rule. It's called the chain rule. It's for the derivative or the rate of change of a composite function. And what is that rule? That rule is, we talked about how if you change x a little bit, how much will f change? Well, it'll change by this much times the change in x, right? And then if you change f by a little bit, how much will g change, right? So as x changes a little bit, then f changes a little bit. And as f changes a little bit, how much does g change? It will change by this much times the change in x. Or the change in f, I should say. So this is what we came up with on Tuesday. It's called the chain rule. And it's how to take the derivative or find the rate of change function for a composite function. So we call f the interior function, and then g is the exterior function. So our interior function here is 10x, so we're going to start with the rate of change of the interior function, which is 10. So rate of change of the interior times, what does this say? Times the rate of change of the exterior with respect to the interior, which means leave the interior as it is. So what is the rate of change of square root? 1 over 2 square root. Now, with respect to f, as it is, you leave that interior function as it is. That's the most common mistake students make, is they do g prime of f prime. That's the most common mistake, g prime of f prime. No, we want g prime of f. Leave that f as it is for our interior function. So that's the chain rule for that first term, square root of 10x. And then here's another thing that students really struggle with. When you have 4 over x cubed, what is that the same as? We want to get rid of, so we need this to look like something we know, which would be 4x to the, all right, so this, you got to know that rule for an exponent. If you forgot it or you never learned it, you should have learned it. Learn it now. That 1 over x cubed is the same as x to the minus 3. 1 over x cubed is the same as x to the minus 3. So we're taking the derivative of 4x to the minus 3, so we're going to apply the power rule. Negative 12 x to the negative 4. And then we have minus e. Minus e is a constant. Rate of change of a constant. 0. We're done. So on the mastery test, you do not have to simplify. In fact, you're instructed not to. So if this were a mastery exam problem, we'd be done. We would not, you don't even do 10 divided by 2. So in any other case, that would be entirely appropriate. To do 10 over 2 is 5. But for purposes of the mastery exam, you apply the rule and you stop. No simplification at all. Yes, sir? Same thing, yeah. So yeah, you could leave it as x to the minus 4 or over x to the 4th. Doesn't matter. This is fine the way it is. Other questions? Yes, sir?
Beginning with the square root of 10x?
Yeah.
Make the square root of 10 and the square root of x?
Yep.
Okay.
Yep.
And then wouldn't you get square root of 10 over 2 square root of x?
You'd get square root of 10 times 1 over 2 square root of x.
So that's the same thing, no?
Yeah, because if you took the square root of 10 out of this, then 10 over the square root of 10 would be square root of 10 in the numerator.
Okay.
You see that? Yeah. So combining just that square root of 10 with that 10 up there gives you the square root of 10 up here. Yeah. Yep. So yeah, that you could also do that. But that's a nice little practice anyway. The way I showed it was a nice application of the chain rule. Other questions on this? Yeah. Yes, you will get penalized. How about that? It's just for grading purposes. It makes it much easier for us. So, yeah, just try not to. Yeah, some things will be very tempting to do, like 10 over 2. Of course, that's 5. Just try not to. Yeah.
Could we leave the square root of 10x as 10x to the negative 1/2 power?
Yeah. Mm-hmm. Okay, so let's talk more about the mastery. Here we go. So the mastery is 1 week from tonight, the first attempt at it. The way it works is, in order to pass the mastery test, you must get 90% correct. If you get 90% correct or more on the first attempt, then your score, your grade is 100. Okay? So as long as you get 90% or more, you get 100 on the exam. But if you don't get 90% on the first attempt, then you have to do it again. This is why it's called the mastery exam. And so when you do it on the second attempt, you still have to get 90% of everything correct, but you're not going for 100 anymore. You're going for a 90. So your score, so by not passing it on the first try, you disqualify yourself from getting the 100. So we just want to pass it the first time, because you're going to keep taking it till you pass it. So let's pass it the first time and let's all get 100 on it. We'll all get 100, all right? Okay, so the first thing about that is we have to memorize the basic rules of all our basic functions. So this is will be posted on Blackboard. It's going to open up right after class. You'll have this sheet. So what is this sheet? This is about just the basic rules. So all these over here on the left, this is saying here's your function is a constant, derivative is 0. X to the n, we know that one. Power rule. Square root of x, we know that. Exponential functions, we know that. E dx, we know that. So here's first new ones here. If the function is a log base b of x, then the rate of change or the derivative is 1 over x ln of b.
That makes sense for ln.
And so then the special case of that is the natural log of x. So when the base is e, you have the natural log, then the rate of change is 1 over x. Okay? So we didn't show this, we didn't prove it, we don't have time to prove them all, but you have to know all the basic derivative rules. Okay, now the trig functions. I think, did you do sine x in recitation? At least some of you did in recitation. Okay, so the derivative of sine x is cosine x. The derivative of cosine x is minus sine x, etc. So the ones I'm putting a box around here are ones you're going to need later in class today. So eventually you have to memorize this whole list, which we've already got pretty much the first column done. So it's a matter of memorizing the second column and then this third column for the inverse trig functions. But really, there's only 3 things to memorize because each one has sine inverse is that for the rate of change. Cosine inverse is just the opposite of it. Same with tangent and cotangent, it's just the opposite. Secant inverse, secant inverse, just the opposite. So there's really, in this right-hand column, there's kind of like only 3 things to remember, along with that you're going to take the opposite for the kind of the companion function, right? Okay. But for the rest of class today, go ahead and write down in your notes these. You're going to need these in the rest of class today. Yeah.
Is there only like 2 things considering the inverse tangent and inverse tangent, or just the other 2 applied by each other? Inverse cosine has inverse sine gets the inverse.
No. That's not right. These 2 multiplied are not this. No. Okay, got those jotted down. So this list, you can print this out when you're working on practice problems. You can print this out from Blackboard, and I'll show you where it's going to be on Blackboard. But this is all our basic rules that we have to have memorized. Okay, so let's pick up and start. You've done some of these using the chain rule. Let's do some more chain rule problems. But now using those some of these other rules that I just showed you on the previous screen. So the cosine of natural log of x, the first thing we need to recognize is this is a composite function. It's the interior function is, what's the interior function here? Got my list. Natural log of x is the interior function, and the exterior function is cosine of x. So we're going to apply the chain rule. So now I've got the order different. So with multiplication, the order is, you can change the order in multiplication. So now I'm kind of, I have it reversed from how we proved it on Tuesday. So in understanding it, we saw that this, we changed x a little bit, and then we got a change in f. That gave us, that's why we did this. And then by changing f a little bit, then we had the rate of change of g with respect to f. So, but I'm going to change the order. Most times when you're applying it, you do this first. So we look at the exterior function. So we said the exterior function was cosine. So we want the rate of change of that exterior function cosine, which is negative sine of, here's the thing that lots of students forget and you blow it. You leave it, the interior function as it is. So it's the rate of change of g with respect to f, not with respect to the rate of change of f. It's not the opposite. It's not opposite of sine of 1 over x. It's opposite of sine of, trying to get your attention, because this is the biggest mistake when I'm working with students and they're trying to pass the mastery test and they're doing these big, long, involved problems. This is the most common mistake that I see. In applying the chain rule, students will do minus sine of 1 over x. Do I have your attention? Don't do that. But now, here's the chain part, times the rate of change of the interior function, which is, there's our 1 over x. So this may seem simple here in the simple problem, but when the problems get very complicated and involved, this is the very common mistake that I see. Students will do something like minus sine of 1 over x. That's not what the chain rule says. It says minus sine, or the derivative of the exterior with respect to the interior, not the rate of change of the interior. And then times the rate of change of the interior. Okay, next one. What is the exterior function? Log base 5. So from that rule that you just wrote down, rate of change is 1 over that. Okay, 1 over that, right? So 1 over whatever's the interior function not the derivative of it, times natural log of 5. So I just applied the rule for log, but then times, chain rule says, times rate of change of the interior, which is? So just applying the rule here. We're just applying the rule, rate of change of the exterior, keeping the interior as it is, then times rate of change of the interior. Okay, so you've got 3 to do here on your own. Work on these. See how they go. Questions? If you're not sure, ask. Okay, where's Muhammad Habash? Muhammad Habash. Guadalupe Batista. Guadalupe, yeah. Tell me what the exterior function is for this third example. What's the exterior function? What's that? Yeah, something squared, right? The exterior function is something squared. And what's the derivative of something squared? Right. Okay, so we're going to bring down the 2. And then it's going to be to the first. So what's inside? Leave it as it is. Remember, leave it as it is. And then that'll be to the first. And then, are we done?
No.
Keep going, you're doing good. Yep, so yeah, this way is fine too. So you get 1/2 x to the minus 1/2. Or 1/2 square root of x, same thing. What about the e cubed?
That guy.
Okay, so is the rate of change e cubed? Is it 3e squared? That's a popular one, 3e squared. This is just a number. If you take a number and cube it, you just get another number. Rate of change of e cubed is 0. So we're done. So you could just write it like this, or we could have done this. Same thing. We could have done this. Just to emphasize, right? Emphasize the derivative of e cubed is 0. But what we had before was also this equivalent. Questions on this one? Okay, what's the overall structure of the next problem? Where's Ori? Is Ori here? Usually down here. Oh, he is here. Okay. What's the overall structure? What rule, in the biggest sense of this next one, are we going to apply? Remember? Okay. Is the overall structure, the chain rule, a composite function of that one? It's not. What is it instead? Someone said it. Constant multiple, right? We have a constant 6 times, this is a composite function. So we have the constant multiple rule, which says that the rate of change is just the constant multiple times the rate of change. You just hold on to the 6. So we're going to do 6 times the rate of change of 7 to the tan x, whatever that is. So now, looking at the 7 to the tan x, what's the overall structure of that? Okay? And what's the exterior function? Let's see. What's the exterior function for that? Where's Nicholas? Can you tell me, Nicholas? What's that? Yeah, so the overall structure is 7 to the tan x. So it's like exponential function. The overall structure is exponential function, 7 to the something. So what is the rate of change of 7 to the something? It's just 7 to that something times natural log of 7. Now that's just this part, right? That's just the rate of change of 7 to the something. So we're not done. Then times the rate of change of the interior function. So this is this part right here. That whole thing is our RG fx. Now we need times RFX. And what's that? Secant squared is the interior function is tangent x, so that derivative is secant squared. And then that whole thing times 6, because we have the constant multiple rule. Questions on this one? Okay, so then the last one, what's the overall structure of the last one? Where is Ismael Guerrero? Ismael Guerrero? No. Kenneth Kowalski. Where's Kenneth? What's the overall structure of that last one? Square root. Square root. Our exterior function, g, is a square root. So we're going to do the rate of change of a square root function, leaving the interior as it is. So what will that be? Go ahead. We'll do
1
it.
over 2.
1 over 2.
Times the square root of 6 times 7 to the negative x minus cosine of x.
Right. That's the rate of change of square root. Okay? That's this part. That's the rate of change of square root with respect to what was originally under the square root. We're not going to change that. And then times times the rate of change of the interior. What's the rate of change? What's the structure of the interior? Subtraction, right? Subtraction or addition. And so we're going to do the rate of change of the first minus the rate of change of the second. What's the rate of change of the first? We already did it. Right? So this is the name of the game, that we're going to see rules used within rules. We already did the rate of change of 6 times 7 to the tan x. It's going to go right there, what I put in blue. And then what about the rate of change of cosine of natural log of x? We already did that rate of change of cosine natural log of x. That's going to go there. And then we're going to subtract. So what is it? It's the chain rule within the chain rule, right? So the overall structure is square root. 1 over 2 square root times the rate of change of what's inside, or the derivative of what's inside. Well, what's the derivative of what's inside? Well, each of those is its own chain rule. So we got to do the derivative of 6 times 7 to the tan x. That goes there. Minus the derivative of cosine natural log of x. That will go there. And then we'll have the whole thing. This is the name of the game, is we're going to see these rules in combination. So the whole thing was chain rule, and then when we got to this, the rate of change of the interior, that involved chain rule. So I'll give you a second to digest that and ask a question if you have a question. Does it make sense? Don't think to myself, oh, I'll just learn this later. This is a great opportunity to start thinking about, oh, I'm studying for the mastery. Okay? Tune in. Okay, tune in. Any questions? Yes, sir.
Is it always minus on the bottom, or just because of the negative sign?
This minus or this minus? This one?
Yeah.
Well, because we're doing the derivative of one function minus the derivative of another function. So that minus just came from that minus. So if that had been plus, then that would be plus. Does that answer it? Yeah. Yeah. Other questions? Okay. Can I erase? We're good. Okay, so what we haven't done yet is functions that are products of other functions or quotients of other functions. So for instance, if f was sine x and g of x was e to the x, and then we made a new function that was f times g, or sine x times e to the x. So the question is the derivative of k the derivative of f times the derivative of g? Is the derivative of k just the derivative of f times the derivative of g? Kind of like we saw with the addition rule, right? To get the derivative of the sum of things, it was just the sum of the derivatives. Does the same hold here? Wouldn't it be nice? It would be really nice, but it's not true. It's not true. Similarly, for a quotient, the rate of change of a quotient is not the quotient of the rates of change. Okay? It's not the quotient of the rate of change functions. So we've got to figure out what these rules are. So we're going to take a look at a product first. So here's a product of two functions, f times g. How are we going to start? So we want to come up with a shortcut rule for whenever two functions are multiplied together, what's the rate of change of the product? So if we want to derive that rule, how do we start? How do we start? Where is Michaela Watkinson? think she said she was going to be gone. Okay, where's Jackson? Merton? Jackson here? Okay. Where's Hungry Zhang? Where's Samuel Bundy? Samuel, how are we going to start? If we want to derive a rule for the product rule, for the product, what are we going to start with? Okay, how about, where's Darren Sims? Darren, how are we going to start? What's that? Find the derivative of f? Nope.
We just start with our basic function. The one that we think is
Right. We want our trusted form of the rate of change function. Yep, the trusted form of the rate of change function, which is going to be the function evaluated at x plus h minus the function over h. But our function is an f now. Our function is f times g. So what's that going to look like? It's going to be f of x plus h times g of x plus h, or the function evaluated at x plus h minus the original function all over h. So we know for sure this is right, because this is our trusted form of the rate of change function. So what are we going to do with this? So here's what you do with this. Oh, you guys. Look, all I did, so here's, the black is what was there originally. The red stuff is the new stuff. We got f times, so minus f times g plus h plus f times g plus h, which essentially is what? That's just 0. That's just 0, right? Because it's the opposite, or negative value plus the value. So what do? We just kind of inserted 0 into the numerator, which doesn't change the value, so they're still equal. Okay, so why do we do that? Because it works. Okay, it works. Here's what happens. So mathematicians, they've got lots of time on their hands, and they figure this out, that this works. Here's what happens. So we're going to gather up now the first two terms. We're going to gather up the original term plus this one, and then we're going to gather this one plus this one. And when we do that, we notice that both of the first two have a g of x plus h. And both of the last two have a f of x. So we're going to factor out the g of x plus h, and that's going to leave f of x plus h minus f of x. And then we're going to factor out the f of x, and that's going to leave g of x plus h minus g of x. So look at what's happening here. Do you recognize that? Okay, also, so that thing that I put a blue bubble around, what is that? Andrea Lopez. Where's Andrea Lopez? What is that thing I put a blue cloud around? Yeah, that's the rate of change of f, right? And so then, and over here, g of x plus h minus g of x, also over h, that's the rate of change of g. So that's why we put those red terms in, because then when you gather them with the original terms, you can get the rate of change of f and the rate of change of g. So there they are. So then when h gets very, very small, essentially 0, g of x plus h becomes g of x. And then these ratios here, these fractions, become our rate of change of f and our rate of change of g. So we get this formula. We get, I switched the order there, so f times the rate of change of g plus g times the rate of change of f. So what does it say? It says that the rate of change of a product of functions is, this is how you would say it in words, the first times the rate of change of the second, plus the second times the rate of change of the first. Again, what is it not? It is not the rate of change of the first times the rate of change of the second. Okay? Instead, it's you take one of them times the rate of change of the other. Then you reverse that. Then you add them together. Okay? So you take one as it is times the rate of change of the other. Then you do the reverse of that. You add those two things together, and you got it. So this is kind of easy. It's easy to memorize because addition is, you can switch addition, you can switch multiplication. So it's kind of hard, as long as you know the general structure, it's hard to get it wrong. Okay, so let's apply it. So here's a function whose overall structure is product. Remember, identify structure first. We know it's the product of two functions. So since the function is called f, we'll call these g and h now. We'll call these g and h. And so what does the product rule tell us then? It's going to be the rate of change of f. Product rule tells us that right? Yeah, so it's going to be g times h prime, or derivative of h, plus h times g prime. So that's our roadmap for this problem. So identify or label that first function as g, or whatever you want. You do p and q. If you want to do p and q, that's fine. So second function as h, and then the derivative will just simply be g times h prime plus h times g prime. So all we have now to do, we already have g. We just need to find what is the rate of change or the derivative of h. What is it? Just 6x. And then we need the rate of change or the derivative of g. 8x cubed. So we've got all the pieces. We just got to assemble the pieces now. We've got all the pieces. G, h prime, h, and g prime. We've got all those. We just write it down. Just assemble the pieces and write it down. You do that. So you do the next step before I put it up there. So what is, we're all ready just to write down the answer now. Cole. Where's Cole? Usually right here. Where is he? Somewhere else today? Where's Cole? Oh, there you are. You're one row back today. So tell me what the derivative of f will be. Where did I lose you? Where did I lose you?
I was writing notes down.
What's that?
I was writing notes down.
Writing notes down. Okay. Where is Justin Chandler? Tell me, what's the rate of change of f?
You want the pieces?
I want, just tell me verbally what I'm about to put on the screen. What's the rate of change of f?
2x to the fourth minus 3
Right.
6x
Right?
plus 3x squared plus 7 times 8x.
Times. Yeah. Yeah, you got it. Just typo. Verbal typo. Verbal typo. Okay, does it make sense? All right, does it make sense? Yeah, so we just, by identifying the structure first and writing, so you can write down the structure of the answer, right? So that if the structure is product rule, then your derivative structure will be, or if the structure is a product, then the derivative will have the product rule structure. So then you just have to make sure you have all the pieces, and then assemble it. So start with the big picture first. Anybody have a question? Yes?
And that answer is acceptance.
Yes. Don't do anything more. No, that's desired. That's desired, not just acceptable. That's what we want. Just stop. Just stop right there. Okay. All right. What's happening? Do you want to share with me what's happening? What's going on? I'm confused. All right, ready to go on? Okay, everybody? They're still talking. Are you talking about math, or what are you talking about? Okay, here we go. So what about a quotient? So to prove the quotient rule, we're actually going to use what we just learned, the product rule. So let's turn the quotient into a product. So it'll be f times g to the negative 1. And now apply the product rule to that in order to come up with what we'll call a quotient rule. Okay, so what would the product rule say? It would say the first times the rate of change of the second plus the second times the rate of change of the first. So that's just applying the product rule that we just learned. So the only thing so we have f is f, and then that's just what, 1 over g, but the question is, what's the derivative of g all raised to the negative 1? What do we have that we're going to be able to get the derivative of g raised to the negative 1 power? What kind of function is that? That's a composite function. You've got an exterior and interior function. Right? So this right here is kind of the only challenging part of this. So the exterior function is to the negative 1. So we'll start with the rate of change of the exterior with respect to the interior. So that's going to be our power rule. So negative 1, leave the inside as it is, to the negative 2 times the rate of change of the interior function, which we're using this notation this time. Remember, we have various notations for derivative. You need to recognize and be able to use them all. So that's just that one part that I put a brace around, right? I'm applying the chain rule to this composite function. Power rule times rate of change of g. So that's just rewriting what I just said. Okay? If you rearrange this, do some algebra, we get it back into fraction form, and it ends up looking like this. So this is a little more brain power needed for this one than the product rule. Product rule is kind of, if you get the overall structure, it's kind of hard to mess it up. But this one will take a little bit of energy to memorize. Okay, but there's a trick to it. So what does it say? It says we're going to take the denominator function, and we're going to call that low. Low because it's low, okay? And the numerator function, we're going to call high. Because it's high, right? High and low. And so this is gonna help us. We're gonna make a little song. We're gonna make a little song to help us remember this. Okay. So using the rate of change notation, it would look like this. Using the prime notation, it will look like this. So that's rate of change notation. That's prime notation. It's the exact same formula. And then here's just a stripped down version of the prime notation, just showing f and g. Okay? So using the high and low, so we're going to say it's going to be low d high minus high d low. So when we say d, we're talking about the rate of change, derivative of. So Low meaning the bottom function. D high meaning the derivative of the top function. Minus high D low. So high meaning the upper function. D low meaning the derivative of the bottom. Over low squared. So low D high minus high D low over low squared. So this is just, like the Seven Dwarves trying to help you learn this formula, okay? If you have another way to remember it, it's fine. This is one way to try to help you to remember it, okay? Okay, please don't all start talking. So, but really, to get you started, all you really need to remember is the first part. If you could just remember the low D high, then you know it's minus the flip of that, and then over low squared. So if you can just, if it's just low D high minus, if you can get that far, you usually can get it right. So low D high minus high D low over low squared. That's the quotient rule, right? If you have the quotient of two functions to get the rate of change, you're going to apply this structure. Okay, anybody have a question? Yes, sir.
Yeah, it's alright if we think about it like F and then G, like in both cases, because I see that they're switched around like after you subtract. If you think about it like F prime G minus F G prime.
If you want to, yep.
But that works.
Yeah, if you want it, he's saying it's more natural for him to do it this way. F prime G minus F G prime. That's perfectly fine. Because they're equal. So he's just switching the F prime and the G up here. But what you cannot do, you can't switch these two. All right? Because it's subtracted, you've got to have, it's got to be the denominator times the derivative of the numerator first. Low D high, or D high times low, whatever you want. But you can't, because it's minus, if you flip those two, you'll get the wrong answer, okay? Okay, practice. So let's practice it. We said tangent x was, the derivative of tangent x was secant squared. So now that we have the quotient rule, we can apply the quotient rule to prove that. Let's prove it. So can we prove it? So what you'll need. What is tangent equal to? Tangent is equal to sine over cosine. And then this very important trig identity, this you should have learned from pre-calc, is that sine squared plus cosine squared of an angle equals 1. So knowing those two things and knowing the quotient rule, we can prove that the derivative of tangent is secant squared. Okay, so in this case, we're not using the rate of change function. We're going to start by saying that tangent x is like we said, sine x over cosine x. See if you can take it from there. So now we're doing the derivative of a quotient. If it's a quotient, we got to apply the quotient rule that we just talked about. So whenever you're taking the derivative of a function that's a quotient of other functions, you need your low D high minus high D low over low squared. So then if you apply that quotient rule correctly and you do the math, what are we expecting to get? What's our goal to get to? Secant squared in the end, right? So we're going to do the math. We should get secant squared. Yeah. What are you saying?
Oh, for the product. For the product. Before it was backwards, so this was right here, this was right here.
Yeah, so multiplication is commutative, meaning you can switch multiplication, and addition is commutative.
Okay.
So there's lots of different ways to get the product rule right.
Okay, so if I just do it like switch, they won't come out.
No.
Okay. Okay.
No, the order in multiplication and the order in addition doesn't matter. But in the quotient rule, you can't do that because you have minus. You gotta have that one first.
Which one?
This one. Low D high has to be first. You can't put that first because that minus that is not the same as that minus that. You can switch the multiplication, but you can't switch the subtraction. All right, where's Diana? Okayo. Diana, Okayo. Did you get the first step? Did you get it? No? Okay. What about Julie? Kostelewski?
Yeah,
I'm sure I butchered that, sorry.
just like talking through it.
No, the first step. So what?
First step, I would do quotient rule.
Okay, good.
I would do the derivative of the top one.
Okay.
Just cosine of it.
Good.
Times the bottom one, which is also cosine of it, so
So
it's cosine of it.
that's our low D high. Low D high. Okay, good.
And then minus the derivative of the bottom, which is negative sin x.
Okay.
Just the top, which is sin x. So you get negative sine squared of x. And then it's like a double negative, just like cosine squared of x plus sine squared
Good. Okay.
over the bottom squared of x.
Okay, so she applied the quotient rule. Low D high minus high D low over low squared. Okay, Adrian, did you get that same thing too? And what'd you do from there? So the numerator turns out to be cosine squared x plus sine squared x. And that numerator is just 1, right? That's the Pythagorean identity. Okay. Yeah, because the definition of secant is 1 over cosine. The definition of secant is 1 over cosine, so if you have 1 over cosine squared, secant squared, and we got it. We're done. So what do? We used the quotient rule to prove that the derivative of tangent is secant squared. Questions on that? Anybody have a question? Yes, please.
This is what we're supposed to do in the masteries. So we're not just simplifying, but
No, this is a little bit different. We were proving a derivative here. So that's a little different than the mastery test. So we knew the answer and we were using other rules to prove what it was. So this a little bit different activity than a mastery problem. Yeah. No, mastery test is just it's just doing derivatives. Just doing derivatives. That's right. Questions on this one? Okay. Again, there'll be moments when you'll wish you had a problem like this. Okay? You think this isn't too bad. So what do? What's the first question we ask? What's the structure? So the overall structure is going to dictate then what the overall structure of our derivative is. So what is the overall structure? It's a quotient. It's one function divided by another. Okay? So therefore, the derivative of g will, its overall structure will be the quotient rule. Okay, so we want to start by naming our functions, right? So what do we want to call this function? Sure. Numerator will be f. So f of x will be log base 2 of 4x. Okay? And then? No, but our function is g. So we don't want to call that g. You keep saying g. We don't want to use g. G is the name of the function. Oh, p? Sure, p. So if we call the numerator f and the denominator, so this is like high, right? This is like high. And this is like low, okay? So then what will the overall structure of our... Okay, so if you're talking about the math, then just whisper, okay? If you're doing the math, that's fine. Just whisper, okay? Can you wake her up? All right, so here we go. So if we're using f is high and p is low, then what is going to be the overall structure of the derivative of g? Using f and p, what will our derivative be? Where's Whitney? Whitney Eba. Where's Jack? Macardo. Jack, what will, so using the functions f and p, what will the overall structure of our answer be? What's that? Okay. What about Muhammad Habash? Second time. Oh, you are here. I called on you earlier. Okay. Using f, just using the symbols f and p, the names of the function. Yep, exactly. So low, he said px times derivative of f, right? Good. How did he do? Low d high minus high d low over low squared. So now we just have to get all those pieces. We already have p and f, so all we need now is f prime, the derivative of the top, and p prime, or the derivative of the bottom. And then we're just going to plug all the pieces into that, because that's the structure of our answer. And we're just going to plug all the pieces into that. So now we come back to f and p, and we need to find each of those individual derivatives of f and p. And then we're ready to assemble it into the quotient rule. So that's what you're working on. Derivative of f, derivative of p. Yes. Not today. Tuesday. Just worry about if you do the homework over the weekend, that's the best thing you can do to get ready for the master test. And then I'll talk about the exact format on Tuesday. Okay, let's see how we did. Levi, you're up. Did you get the derivative of f? Tell me the derivative of f. So I'll put that in red here. Go ahead. 1 over 4x. Natural log of 2. Is that it? Not quite. Because look at what you have. You actually have a composite function here, right? You have 4x plugged into log base 2. So that's the right start, but then what else do you need? So it's a composite function. So we do the rate of change of the exterior with respect to the interior. You did get that good. Times what? The rate of change of the interior, which is 4. Questions on the rate of change of f? That's a little chain rule problem. 4x is the interior function. Log base 2 is the exterior. So you're going to do the chain rule. For when you do the rate of change of f, it's chain rule. You have to multiply by now the rate of change of the interior, which is the rate of change of 4x, which is 4. Questions? Okay. How about the rate of change of p? Ricardo, did you get the rate of change of p? Go for it. This whole rate of change here. So this first part, what kind of function is that? Exponential, okay, so?
It's 3x to the square root of x
3 to the square root of x
times ln of 3
times ln of 3.
times 1 over 2 square root of x.
Right, chain rule. So that whole thing is exponential with something plugged into it, right? So this is chain rule. We're going to do the exterior with respect to the interior. So it's going to be 3 to that times ln of 3, then times the rate of change of the inside function. Keep going. Minus. So this was on that list at the beginning. I forgot to tell you to write it down. But the derivative of cosecant is negative cosecant cotangent. That's just a rule you remember. The rate of change of cosecant is negative cosecant cotangent. We're going to subtract that. So here's our rate of change of p. Ask me if I lost you. Ask me if I lost you. Yeah. Yeah, times. I just didn't have enough room. Questions on that? So now we've got all the pieces for the quotient rule because our original function was a quotient. We're just going to apply all the pieces to the quotient rule. Ready? So this is just writing now. There's nothing hard about this. It's going to look ugly, but it's easy. You're just copying down what you've already done. P of x. Right? That's function p. Times f prime. Minus f. times P prime. Okay, I'm gonna so we would rewrite that in there. All over rho squared, or P squared. Anybody have a question? Yes, please. Yes. Just P squared. Just write P squared. Yeah, that's it. No, don't simplify anything. Just assemble the parts, leave it. Last chance. I'm gonna erase. Okay. Yes, ma'am. Let's get started on this one. Okay, you should be thinking this is the structure, the square root of some function. Square root of some function. So then what will the rate of change be? What will the rate of change function be? The derivative.
1/2.
Yeah, so in terms of g, what will the rate of change function be? Where is Andrew Kanalatu? How about Vincent Bagnara? Where's Vincent? Where are you? What will the, so in terms of g, using the function g, what will f prime be? Just using g, what will f prime be? Yeah. No, don't, just looking at this, using square root of g, what will f prime be? Just, you're going to speak in terms of just g. 1/2 radical. Okay, is that it? But it's composite, right? So you've got the no. Times the rate of change of the interior. Okay, so this is, the structure is the square root of something. Therefore, the rate of change is 1 over 2 square root of that something times the rate of change of that something. This is the chain rule. This is the chain rule. So I switched the order here. So the overall structure is square root, so we're going to apply square root, keeping the interior function as it is, times the rate of change of the interior. That's the chain rule. That's the chain rule because we have a composite function. So then we just have to identify what g is. Okay, and now what's the rate of change of g going to be? We're doing the rate of change of g now. It's because we're going to assemble this. This is what we're going to assemble for our final answer. So what we need is the rate of change of g. So what is that rate of change? Product rule, right? So it's 7 to the x times tangent x. So we're going to do the first times the rate of change of the second plus the second times the rate of change of the first. We apply the product rule there. And then plus the rate of change of sine. So what did I do? I did the first times the rate of change of the second plus the second times the rate of change of the first. So when I get to g prime, part of that is doing the product rule. And then plus the rate of change of sine, which is cosine. Ask me if I lost you. Do you follow that? So now we've got everything we need because we know our answer is going to be according to the chain rule on the square root of g. And then we're just going to plug in g prime now. Assemble it. G prime and g. So there's our g prime that we just found. 1 over 2 times g, square root of g. Anybody have a question? Let me just, yeah.
What's the rule did you apply?
Well, the overall function, it was the chain rule, square root of gx. When I do g prime, I look at g. What is g? Well, the overall structure of that is a sum, first of all. And then the first one is a product. So I need the product rule for the first one. And then plus just the derivative of sine. So it's product rule plus derivative of sine. And that's it. And then I just took those parts and put it into our overall derivative. Did it help?